Hi guys, let's start a new chapter. It's called Statistics, which is chapter number 18 in your textbook. So let's see what is statistics. We've done this in 8th standard as well. In fact, yeah, in 8th standard as well. What is statistics? Statistics is basically a branch of mathematics that's concerned with how information or data is collected, organized, presented, and analyzed to make decisions. That's basically statistics. Uh, and we will need to use this branch of mathematics extensively when we start working, and when we whichever work we field we choose, this will be extremely important for us. Now variable, so let's look at the next one, continuous variable. Now what's a variable? A variable is any quantity which can change. For example, what's the shoe size of the students of the classroom? Well, it'll be 3, 4, 5, 6, 7, 8 maybe for someone. So this is, so shoe size is a variable. What are the marks of students? Well, someone will score 34, 35, 36. Those are again variables. So continuous variable is a variable which basically is continuous, which means, let's say for example, height of a student. So height of a student would be, let's say, 145 centimeter. For someone it could be 145.6 centimeter. For someone it could be 139.8 centimeter. For someone it could be 152.7 centimeter. So this is in continuous. You can have height which is 130.1, 130.2. Basically data which is in the form of decimal is a continuous variable. Next one, what's a discrete variable? So discrete variable is basically a data which is in whole numbers, maybe natural, yeah, basically whole numbers, full numbers, not in decimals. So for example, number of students in the classroom. So number of students in a classroom will always be 1, 2, 3, 4. You cannot have half a student. That's why this is discrete. This is it can either be one number or the next one, nothing in the middle. Another example, let's say, what are the shoe sizes? Like I said earlier, shoe sizes of students. So someone can have a shoe size of 6, someone can have 5, someone can have 7. There is no 5.1 shoe size. That's why this is discrete. Next is raw data. Now data like what I presented in part 2, which is in no form, which means it can have lower value, up higher value, mixed one. So this is 145, then I increase it to 145.6, then it reduced to 138, then it increased to 152.7. So this data which is in the basic form, which is the way it is collected, is known as raw data. As soon as you arrange it in either an ascending order or a descending order, so in some form of order, then you get a arrayed data. ARRAYED, arrayed data, which is basically arranged in ascending or descending order. Tabular data, let's say in a school you have boys and girls. So in class 8A you have 20 boys and 19 girls. In 8B you have 17 boys and 20 girls. So this data is presented in the form of a table. So basically this is tabular data, data which has been put in the form of a table. Now frequency, what does frequency mean? So frequency basically is the number of times something occurs. So for example, 20 boys, so 20 is the frequency of boys in class 8A. The boys will occur 20 times in class 8A. Similarly, 19 is the frequency of girls in 8A. Now when the data is present, so this is basically frequency. What is ungrouped data? Exactly the way I presented right now in part 6 is ungrouped data. So let's look at another example. Let's say shoe sizes of people or students. So 3, 4, 5, 6, 7. This is my frequency. Usually you write it as small f. Usually you will write it as small f. Let's say 10 boys have this shoe size, 7 here, 3 here, 4 here, and 1 here. So this is my ungrouped data. Why ungrouped? Because I know the exact values. It is not written in any grouping, which means 10 boys have shoe size 3, 7 boys have shoe size 4, 3 boys have shoe size 5. Now let's look at grouped data. Now grouped data would be when you group the something together. So let's look at marks. Let's say I am looking at marks and I'm looking at frequency. So students scored 1 to 10, 11 to 20, 21 to 30 and 31 to 40. Let's say one student scored here, 1, 2 here, 15 here and 15 here. It was a 40-mark test and this is how our marks are distributed. So what was the marks scored by the 15 boys? Well, I don't know whether it was 31 or 40, but it was in this group. So this is known as a grouped data. Perfect. So now let's move on and see the next part of this. So in this, the next part is inclusive data. Now, if you look at the previous one which I had given, where also this is also known as discontinuous class interval. So let's look at this example. In my previous example, I had looked at marks in this form: 1 to 10, 11 to 20, 21 to 30 and 31 to 40. So this is known as a class interval. So this is known as a class interval. Some people also call it the boundary. So this is my first class interval, this is my second class interval, this is my third class interval, and in this case this is my fourth class interval. Now lower limit, as the name suggests, this is the lower limit of this class interval, this is the upper limit of this class interval. Similarly, this is lower limit, this is upper limit. So this is basically it, lower limit and upper limit. Now let's look at inclusive data, or also known as discontinuous. This word is used more commonly, which is discontinuous. In this case, if you notice that the upper limit of one class interval and the lower limit of the immediately next class interval is not equal. In this case, this is 10, in this case it's 11. So this kind of data where the upper limit of one and the lower limit of the next one is not equal is known as discontinuous. Now comes the next one, continuous class interval. How would it look like? Well, if this is discontinuous where it is not equal, then the continuous would look like when it is equal. So 0 to 10, 10 to 20, 20 to 30 and 30 to 40. In this case, the upper limit of one and the lower limit of next one is equal. So this is known as exclusive or continuous. Continuous is the word which is used more frequently. We talked about class interval in any case. Now the next step would be if I need to convert a discontinuous data into a continuous data. How would I do that? And why is it important to do it? Well, this plays having this data in the continuous form is very important when we graph it, which means when we represent it graphically, it is very important. So that's why it is important that we do this for graphical representation. It's very important. So let's look at how would we convert it. So for that we need an adjustment factor. What's an adjustment factor? So you look at the lower limit of one and the upper limit of the previous one. So lower limit of one and the upper limit of previous one. Lower limit of one, upper limit of the previous one, and subtract them. So 11 minus 10 and divide it by 2. So this is 1 upon 2, which is 0.5. So now that you've got 0.5, you will add it and you will subtract it. So I'm writing it as plus minus. So you will add it and subtract it. So where will you add it and where will you subtract it? So you subtract it from the lower limit and you add it to the upper limit of each class interval. Of each class interval. I repeat, you add it to the upper limit and subtract it from the lower limit. So in this case, it will be 1 minus 0.5, which is 0.5, and 10 plus 0.5 will be 10.5. Similarly, the next one will become 10.5, 20.5, 20.5, 30.5, and 30.5, 40.5. Now that you notice that the upper limit of one and the lower limit of the next one is equal. So now I have converted my discontinuous data into continuous data by using adjustment factor. Now what is so this is it. Now this is known as the original class interval and this is known as the actual class interval. So the converted in the continuous form, this is the actual class interval. This is the original, or it may be given in the question, but this is the original class interval and this is the actual class interval. So remember this word actual class interval because you will need to find it in some questions. Next comes the class size. So class size would be the actual upper limit minus the actual lower limit. So in this case it will be, let's say, 40.5 minus 30.5, which is equal to 10. Please note that had you done this class size without converting into actual class intervals, your class size would have been 40 minus 31, which is 9, and this is wrong. This is not the class size, this is wrong. Right? So this is not the way of doing it. If the question asks you to calculate class size, first you will have to convert into actual class interval. Now in case the data is given in the continuous form, well, it's already given in the continuous form. So for this, the class size would have been 30 minus 20, which is 10. Perfect. So let's look at our next one. So what do we have in the next one? Let's see. So class mark. Now what is class mark? Class mark basically is the midpoint of a class interval. So it's basically a midpoint. Now does it matter whether the data is given in continuous or discontinuous? Let's look at it. So if I have to find a class mark of the data point which was 0 to 10, 10 to 20, 20 to 30, in this case my class mark would have been, how do you find the midpoint? Well, you add them and divide by 2. So 10 plus 0 divided by 2, which is 5. This will be 20 plus 10 divided by 2, 15. 30 plus 20 divided by 2, that's 25. So this is my class mark, midpoint. Perfect. So this is my class mark midpoint. Now let's look at if the data was in the discontinuous form. So I had 1 to 10, 11 to 20, 21 to 30. Now this is in the discontinuous form. Right? So how do I calculate class mark? I'm not giving the answer. Let's check. So I will do 10 plus 1 upon 2, that's 11 upon 2, that's 5.5. 11 plus 20, that's 31 upon 2, that's 15.5. This is 51 upon 2, which is 25.5. Now we had already converted this into actual class interval, and the actual class interval was 0.5 to 10.5, 10.5 to 20.5, 20.5 to 30.5. Yes, this is correct. Now if I have to find the class mark using actual class interval, what will it be? 10.5 plus 0.5 upon 2, which is 11 upon 2, which is 5.5. So you notice that class mark does not matter whether it's given in the discontinuous form or given in the actual class interval form. Right? So you can use whichever way you want. Now range of data. A range of data is basically for a raw data where you need to figure out what is the range. So what does range mean? The lowest data point and the highest data point, that's my range. So let's look at question 4D. For a minute, this is exercise 18A. Why am I starting? Well, this is just 1 point, so I want to look at this data, which is range of data. So I have data given is 7, 13, 6, 25, 18, 20 and 16. I need to calculate the range. So range will be equal to the maximum number minus the minimum number. So what's my maximum number in this case? Maximum number I think is 25. Yes. So 25 minus, what's my lowest number? 6. So 25 minus 6. So my range is 19. So that's the range. Cumulative frequency. What is cumulative frequency? Cumulative frequency, let's say, I'll give you an example, it'll be easier to understand. So let's say this is marks and I have frequency. Right? So this is 10 to 20, 20 to 30, 30 to 40 and 40 to 50. My frequency is 4, 9, 5 and 6. What will be the cumulative frequency? Cumulative frequency, as the word suggests, cumulative, which means added up, right? Cumulative means to add. So cumulate means to add. So this is 4, there is nothing before this. I add 9 plus 4, I add this. So this is 13, 13 plus 5, 18, 18 plus 6, 24. In case you want to look at a you want to memorize it, in case you want to, then this is a pattern that you can use, right? So you go from here, go to the cumulative frequency, come here, add it, go to 13, add it, go here, add it, go here. So this is basically a pattern in case you want to remember it. Otherwise, basically cumulative means to add. Done. This table that I have just shown you right now can also be written in the form of a less than table, a less than cumulative frequency table. Now what does less than mean? Now this question means that, so if I look at this table, all 24 students scored less than 50 marks. Is this clear? Yes, 24 students scored less than 50 marks. 18 students scored less than 40 marks. 13 students scored less than 30 marks. 4 students scored less than 20 marks. So I can also write this as my class marks can be written as less than 10, less than 20, less than 30, less than 40, less than 50. So if this is given and a number is given here, then what we are looking at is cumulative frequency. So less than 10, or is less than 10 is not given, so less than 20 is not given as per this. This is 4, this is 13, this is 18, this is 24. Less than 10 not given. What we know is 24 students scored less than 20. Less than 10 not given from this data point. Perfect. So now let's move on and let's see if we can start some questions. Let's look at question number 2. So question number 2 says given below are the marks obtained by 30 students in an examination. So these are marks listed of 30 students. Taking class interval as 1 to 10. So I have already written that class intervals are 1 to 10, 11 to 20, 21 to 30, and the last one is 41 to 50. Make a frequency table. So we've done this earlier. We make tally marks because it's easier to count. Otherwise, if I have to count 8, 9, it will become very difficult. So I make it in the form of tally. So now let's start. I have, so 8 will fall within 1 to 10. So this is gone. I prefer to keep striking off the number with a pencil when I am doing it, so that I don't end up missing any number. 17 will be between 11 to 20. 33 will be between 31 to 40. 41 is here. 47 is between 41 to 50. 23 is between 21 and 30. 20 is 11 to 20. 34 is between 31 and 40. 9 is between 1 and 10. 18 is between 11 and 20. 42 is between 41 and 50. 14 is between 11 and 20. 30 is between 21 and 30. 19 is between 11 and 20. If you remember your tally marks, you draw 4 vertical, and then you cross to make a group of 5, easier to count. So this was my 19. Next is 29, which is 21 to 30. Next is 11, which is here. Next is 36, which is here. 48 is between 41 to 50. 40 is between 31 to 40. 24 is between 21 to 30. 22 is here, so I make the fifth one. 2 is 1 to 10. 16 is 11 to 20. 21 is 21 to 30. 15 is 11 to 20. 32 is here. 47 in the last one. 44 here. 33 in 31 to 40, and 1 in the first one. Now I count, this is 4, This is 5, 6, 7, 8, one group and 3 extra, one group and 1 extra, that's 6, one group and 1 extra, that's 6, one group and 1 extra, that's 6. You should always check your answer. So let's check what is my total. That's 6, 12, 18, 26, 30. The question said we are giving you data points of 30 students. So done. Let's look at question number 3. Question 3 said marks of 24 students in the subject mathematics are given below. Maximum marks are 50. Make a frequency distribution table taking class interval as 0 to 10, 10 to 20. So this was discontinuous and now I have continuous. So I am making a continuous data class interval. Now I have already written 0 to 10, 10 to 20 and my last class interval in the table is 40 to 50. Should I have a class interval of 50 to 60? No, because the maximum marks are 50. So then I cannot have a distribution which is 50 to 60. So there is a peculiar problem that will happen in this type of question. When you have a question when you have a marks which is 10, will you put 10 here in the first one or will you put 10 in this one? Because 10 is occurring in both of them. Right? So this is a problem which will occur. So let me answer that problem right now, or let me give you the solution. If there is a 10, it will always appear in the class interval where 10 is the lower limit. So here it's the upper limit, here it's the lower limit. Where will 20 appear? It will always appear in the one where it is the lower limit. So 20 will appear in the third class interval. Similarly, 30 will appear here, 40 will appear here. What about 50? 50 is a unique in this case because my last number is 50 and I do not have a data point after 50. So here 50 will appear in this one only. I repeat, any number will appear in a class interval where it's the lower limit. So let's look at it. 45 comes in 40 to 50, 48 is also in the same one, 15 is between 10 to 20, 23 is between 20 to 30, 30. So this is the issue. 30 will not appear in 20 to 30 but will appear in 30 to 40 because in this one it is the lower limit. 35 will appear in 30 to 40, 40 will appear in 40 to 50 because it is here where it's the lower limit. 11, 29, 29 will appear in 20 to 30, 0 will appear here, 3 will appear again in the same one, 12 is between 12 to 20, 48 is between 40 to 50, 50 is in the last one, 18 is between 10 to 20, 30 again is in 30 to 40, 15 is in 10 to 20, 30 is again in 30 to 40, 11 is between 10 to 20, 42 is in the last one, 23 is between 20 and 30, 2 is 0 to 10, 3 is again 0 to 10 and 44 is in the last one. So let's count. That's 4. This is one full with one extra, that's 6. This is 3, this is 4 and one full with 2 extra, 7. So this is something that you need to notice, that in case you have a number which is my upper limit or the lower limit, then it will appear in the class interval where it's always the lower limit. Right? Now why is this? This is so that this is a convention which has been made by the mathematician so that everyone uses one single method of calculating. Let's look at question number 4. In fact, this is not question number 4. This is question number 5. Sorry, my mistake. Right? So this is question number 5. Let's look at question number 5. Question 5 says find the actual class, lower class limits and the upper class limits and the mid values. Like I said, mid value is also known as class mark. So mid value is also known as class mark. So I need to calculate the actual class limit, lower limit and upper limit of all these classes. So for this, I notice that this is upper limit of 1 and the lower limit is not same. So my adjustment factor, you should always show this calculation because the teacher understands, the person who's correcting your notebook understands how you've got it. So 20 minus 19 upon 2, which is 1 upon 2, which is 0.5. I will subtract it from the lower limit, which means this will become 9.5. I'll add it to the upper limit, so this becomes 19.5. The next one becomes 19.5, 29.5, 29.5, 39.5, and the last one is 39.5 and 49.5. So I'll calculate this is the actual lower limit and this is the actual upper limit. Perfect. Now I need to find the class mark. So how do I calculate the class mark? I add this and I divide it by 2. So 19 and 9, 28. So 29 upon 2, which is 14.5. I could have added this as well. 19 plus 10, 29 upon 2, 14.5. Next one, 29 and 20, that's 49 upon 2, which is equal to 24.5. I notice that it's increasing by 10, so this will be 34.5 and this will be 44.5. Perfect. Let's move on and let's solve the next question. The next question that we do is question number 7. So question 7 says use the table given below to find the actual class limit of the fourth class. This is 1, 2, 3 and 4. So they want me to find the actual class limit of the fourth one. So let's find it for everything. My life will be easier, right? So we will have some practice as well. So adjustment factor here would be upper limit of 1 and the lower limit of the next one. So that's 35 minus 34 upon 2, which is 1 upon 2, which is 0.5. So I add 0.5 to the upper limit and subtract it from the lower limit. So 29.5 to 34.5, 34.5 to 39.5. The frequency is given, I haven't written it here, 7, 10, 12, 13, 8 and 4. I should have written it. Anyway, this is, I subtract 0.5, so 39.5 to 44.5, 44.5 to 49.5, 49.5 to 54.5 and 54.5 to 59.5. Done. So actual class limit of the fourth class. So actual class limits of the fourth class are 44.5 to 49.5. Okay. The next one, class boundary of the sixth class. So this is the last one, is my sixth class. In this case, like I said, the class interval is also known as class boundary. So the boundary is the lower limit and the upper limit. So the boundary is 54.5 to 59.5. Done. Class mark of the third class. So this is what we are looking at. Class mark basically is the midpoint. So how would you find the midpoint? 44.5 plus 39.5 divided by 2. That's 84 divided by 2, which is 42. So that's 42. The next one is upper and lower class limit of the fifth class. So this is the fifth class upper limit and the lower limit. Did they use the word actual? No, they haven't used the word actual. So what is my upper limit? My upper limit is 54 and the lower limit is 50. Why? Because they haven't used the word actual. As per this data, this is 54 and 50. So what is the size of the third class? So size of my third class, which is between 40 and 44. Now if you remember what I taught you earlier, so size is always actual upper limit minus actual lower limit, right? So in this case, for the third class, it will be 44.5 minus 39.5, which is 5. Please note that had you done it without the actual one, your answer would have been 4 and your answer would have been completely wrong, right? Completely wrong. You always calculate class size from actual upper limit minus actual lower limit. Let's look at question number 8, part 1. Construct a cumulative frequency distribution table from the frequency. So I've given you an example earlier. Let's do it. So this is 9. I add 9 and 13. That gives me 22. I add 22 plus 12, that gives me 34. I add 34 plus 7 gives me 41. 41 plus 15 gives me 56. My job to check whether my answers are correct. Let me add from here. 9 plus 3, 12, 14, 21, 26. 6 to carry, 2, 3, 4, 5. Perfect, my answer is correct. Simple? Yeah, very simple. Cumulative frequency. Let's look at question number 9, part 1. Construct a frequency distribution table from the following cumulative frequency distribution. Oh, so now we need to go reverse, which means cumulative is given and we need to calculate frequency. So what it means is 8 people were below 19, right? So that's my frequency of 8. 19 people were below 29, out of which 8 have already been accounted here. So I will subtract. Earlier I was adding, now I'll subtract. So 19 minus 8 will give me 11. 23 are below 39, out of which 19 are already taken care of, which means I'll subtract 23 minus 19. So I will subtract here. I will not subtract 23 minus 11. I'll subtract 23 minus 19, which is 4. Similarly, 30 people are below 49. Out of 30, 23 are already till here, which means between 40 and 49, I have 30 minus 23, which is 7. To check whether I have done it properly, my job to always add frequency. In this case, it should add up to 30. So 7, 11, 12, 20, 0, 2, 3. Perfect. My addition is correct. Let's move on to the next question. The next question that we do is question number 11. Question 11 says, construct the frequency distribution table from the following cumulative frequency table. Oh, this is not question number 11. This is question number 10. Sorry, my mistake. I have taken question number 10. Right? So we are doing question number 10. So we are saying less than 10, there are 6 number of students. Less than 20, there are 15 number of students. Oh, this is not 25. My mistake. I have not written it properly. This is 6, 15, 30, 39, 53, 70. Perfect. Less than 10 is 6. Less than 20 is 15. Less than 30 is 30. So let's look at this question. So I need to first figure out my class interval. So less than 10, so we should ideally look at a continuous table, continuous class interval. So this will be less than 10, will be 0 to 10, because we are talking about, this is not even ages, this is marks. My mistake. I confused between question 10 and question 11. So this is 0 to 10, next will be 10 to 20, next is 20 to 30, next is 30 to 40, this is 40 to 50, and 50 to 60. So what they want me to do is construct a frequency distribution table, which means I don't want to construct a cumulative frequency, I want to construct a frequency distribution table. So I need frequency. So my frequency is less than 10. What is already given, so less than 10, what is already given is cumulative frequency, because this is in the less than form. This cumulative frequency is already given. So this is 6, which means 0 to 10 is 6. Next one will be subtract. 15 students scored less than 20 marks, out of which 6 are already less than 10, which means 15 minus 6, that's 9 students were between 10 and 20. Next is 30 minus 15, which is 15. 39 minus 30, 9. 53 minus 39, that's 14. And 70 minus 53, that's 17. Let's check. 15, 20, 29, 33, 40, 4 carry, 4, 5, 6, 7. Perfect. My answer is correct. So this is we've constructed a frequency distribution table. The last question we do is question number 12 from this exercise. Question 12 says, fill in the blanks in the following table. Class interval is given, and it's a, class interval is given. This is a discontinuous class interval, right? This is discontinuous. The frequency, there are some blanks, and there is cumulative frequency given. So we are looking at the first one. there are 15 people who are less than 34. What is the frequency? 15. Let me just change the color. This will be 15 people less than 34. 28 are less than 44, out of which 15 are already accounted for here. So how do I do it? 28 minus 15, which gives me 13. Or if you do your method of remember the pattern, then this is 15 goes here. You add something to 15 to give me 28, which is 13. And to get from here, I add 28 with 21, that's 49. This one will be 49 plus 16, which is 65. I add something to 65 to give me 73, which is 73 minus 65, that's 8. I add 12 to 73, which is 85. Perfect. Let me check my answer. That's 5, 8, 9, 15, 25, 5, 2, 2, 3, 4, 6, 7, 8. Perfect. My answer is correct. Now the next one is your homework. Homework for exercise 18A is question number 8 part 2, question number 9 part 2, question number 11 and question number 13. Bye for now. Take care. Be safe. I'll see you in the next video with exercise B. Bye bye.